Good afternoon, ladies and gentlemen, and welcome to the inaugural edition of Vaccine Virtual, produced by CPI Industry, publishers of Climate Control Middle East Magazine and Climate Control Journal. My name is Surendra Balakrishnan, and I'm the co-founder and editorial director of CPI Industry. In the last 3 to 4 months, the CPI webinar team has covered several topics of significance, including on how indoor air quality strategies and solutions can help combat harmful microorganisms in the built environment, especially in healthcare facilities. But while indoor air quality solutions and strategies can at best safeguard us, what the world needs most as possibly a defining permanent solution is news of a vaccine that is effective against the dreaded novel coronavirus. Now, the questions that come to mind are, what after we achieve the vaccine? How are we going to get the precious vials across the billions the world over in a manner that would protect the vials from thermal abuse? The world would be foolish to think that refrigeration is homogeneously reliable and that we can gloss over minor breaches with no resulting damage. As we have seen through covering the food cold chain in our publications and associated conferences for over a decade now, a reliable and robust transporter cold chain is still a myth. There are far too many weak links in the chain, and at times the threat comes from the absence of reliable power transmission and distribution infrastructure. So we are faced with a formidable logistical challenge of ensuring the safe passage of thermally sensitive vials of vaccine to the very last mile to the populations the world over, the kind of outreach we perhaps have not seen to date. The objective of Vaccine Virtual, this webinar, is to help us understand and appreciate the challenge and what we need to do by way of preparation. The consequences of failure to reliably deliver the vaccines are beyond imagination. People are dying out there, and as scientists, policymakers, cold chain industry stakeholders, and media, we must do everything in our reach to put a speedy end to the misery and economic uncertainty that has visited upon us. We are privileged to have in our midst a carefully chosen group of speakers, and to lead the discussions, we are equally privileged to have as chairperson Toby Peters, professor in cold economy at the University of Birmingham in the United Kingdom. Professor Peters is also co-director, Center for Sustainable Cooling. He researches system solutions to transition to sustainable cooling and the role clean cold has to play in emerging market transformation. He is a senior advisor on sustainable cooling and cold chain to numerous multinational development agencies. Professor Peters is a regular contributor reviewer to reports and papers related to cooling. He's leading multinational projects to develop sustainable cold chain centers of excellence, as well as international collaborative programs to develop options for sustainable temperature-controlled supply chains for COVID-19 vaccine distribution. He is an award-winning technology developer and industrial academic with more than 14 years of experience in energy storage, energy systems, including policy and regulatory environments, and is one of the inventors of liquid air energy storage. In short, we have a wonderful resource person to lead these discussions. Ladies and gentlemen, I'm delighted to present Professor Toby Peters to you.
Thank you, Surendra, and thank you for inviting me to be here today and lead this panel discussion. I will talk through the biographies of the other panelists at the end, and I think you'll realize you've put together a great group of experts to have a discussion. This is a really important discussion. Researchers are racing to develop, test, manufacture a coronavirus vaccine, but we're also going to need to distribute that globally. And it's going to likely need to be stored between 2 and 8 degrees C. So in short, how do we vaccinate 7 billion people rapidly? Is this the biggest logistical challenge the world has ever faced? Yes, the majority of countries, to a greater or lesser extent, have a temperature-controlled supply chain to collect, store, move blood, vaccines, medicines. However, universal vaccine access is already a major challenge in many developing countries, primarily or especially due to the lack of cold chain and outreach beyond health centres. I think the current logistics chains often lose more than 25% of vaccines due to temperature incursions. So if we're talking potentially about herd immunity, vaccinating 5 billion people, can we afford to lose 1.25 billion vaccines? We're talking next year about having 2 billion vaccines ready. Can we afford to lose potentially 500 million of those? And we're no longer thinking about simply protecting infants, the vulnerable, from preventable diseases, but this is mass population vaccination, urban through to remote communities, in order to protect the economics and continuous operations of nations. For example, in India, 50% of employment is agricultural dependent, and likewise in Africa. Does any country today have the existing infrastructure, resources, data capture and management to meet the demand for COVID-19 to vaccinate the majority of its population rapidly and potentially annually? And as I said, these barriers are really amplified once we move to rural communities, because the last mile is usually the weakest link in the supply chain to get the population out to those rural communities. To put this in context as numbers, India today delivers about 40 million vaccines a month. If India wants to vaccinate 65% of its population, herd immunity over 4 months, it could be looking at actually having to deliver more than 200 million vaccines a month on top of that existing 50 million. Equally, come to the UK, we've got about 7,000 doctors' surgeries delivering about 1.3 million consultations a day. If we want to vaccinate 65% of our population over a period of 2 months, we're going to have to overload or overlay on top of that about 1 million vaccinations a month. So what's the infrastructure and training we need in place for point of use back to manufacture? Can we achieve this without the vaccine preventable illnesses increasing dramatically? Can we achieve this sustainably, economically, socially, and environmentally? And can we deliver additional and lasting value? The vaccine probably won't be ready for mass distribution for about 12 to 18 months. So in my view, this gives us a short window to get prepared. And while the quantum of vaccine cold chain can be estimated considering population sizes, I think the ground level conditions, the last mile point of use conditions of the cold chain, the gaps and opportunities relating to potentially complementary alternative solutions, the local needs, all need to be better understood. And within this, really important is the energy supply and hopefully the potential appropriateness of alternative cooling solutions so we can look at sustainable options. As at today, in the world's poorest countries, reliable electricity supply is a major challenge. In Uganda, I think, for example, more than 70% of healthcare facilities have inadequate access to mains power. But we also have to remember cold chain isn't just about a vaccine fridge. It's actually all the pieces which have to work together, the pallets which move it in the planes, the vehicles that move it to the local health centres, and then the motorbikes and the people that take it right out to the remotest communities. All these have to work seamlessly. And I think this is really sort of where we want to start thinking, that mass vaccination for COVID-19 will require a new approach to assess, re-engineer, and build upon available cold chain logistics assets, not just cold chain for vaccine at a scale and speed never before considered, while, this is so important, still protecting existing immunization needs. And as I said, we've got to make sure this uplift in energy demand and technology demand doesn't come with an environmental penalty. So, but I think with planning, we can build out better with positive legacy. We can create long-term health logistics frameworks that are cost-effective and responsive to future needs and challenges, whilst developing the pathways to a net zero health cold chain. And by evaluating, among other things, new strategies for modal shifts, the presence and appropriateness of alternative cooling facilities, we can provide governments with cost-effective interventions and alternatives to meet this challenge. For example, dare I say, the majority of food cold chains, as at today, don't handle medical supplies. But should we be thinking about creating a new emergency approach which gets part of the food cold chain ready as backup to humanitarian logistics, as and when necessary? Equally, for last mile and point of use, can we start looking at new logistic models, modal shifts, and new equipments? The scope to utilize food logistics capacity in developed countries or temporary facilities, inflatable cold rooms, creating decentralized cooling hubs as potentially lifeboats close to demand, and the role of drones, electric cargo bikes, off-grid solar fridges for lasting remote outreach in developing countries has to be evaluated. And this also has to be done in time to build out as required. And to throw further challenges, we also need the trained health workers to deliver the vaccines and the processes for data capture, as well as the engineers to maintain the equipment. And of course, every vaccine needs to come with appropriate single-use PPE. Getting this right is vital on so many levels, but planning may enable, I think, for choices to be optimized and the short-term results to be delivered, while simultaneously building a system and infrastructure that will give lasting value in the future. Because whilst COVID-19 is potentially an outlier, and it's unknown if we shall have a one-time vaccine or need annual vaccination, we're likely to see an increase in shocks, natural disasters and epidemics, which require, I think, a rethink of emergency humanitarian logistics in a warming world. And so we should use this window to serve as a springboard to consider how to achieve resilience in humanitarian logistics to meet the global medical supply chain at regional, national levels for natural disasters and epidemics, and in a world without reliance on dirty fossil fuel sources. So to discuss some of these points, I'm very pleased to welcome to the panel 5 experts with a unique portfolio of knowledge and experience. We have Arvind Surange, who's the Chairman and Managing Director of ACR Project Consultants. He's a fellow of ASHRAE, previously the National President of ISHRAE, co-chair of Non-Conventional and Sustainable Cold Chain Committee. As CMD of ACR, he's handled more than 700 projects, introduced many technical innovations, including the first ever green cold chain concept on global scale. We have Harshal Surange, the Director and CEO of ACR Project Consultants. He's handled more than 250 cold chain projects in India and abroad. He's a cold chain expert with World Food Logistics Organization and the Asian Development Bank. He co-chairs ASHRAE's Refrigeration Committee and is the past chair of ISHRAE's Refrigeration Committee. And he's won multiple national and international awards for cold chain design. We have Dr. Wasif Alam, an independent consultant and former director of Public Health and Safety Department of the DHA. He has 18 years of expertise in global public health practice and comes with a proven record in prevention and control of communicable and non-communicable diseases. He served 10 years in senior management positions in infectious disease control programs across a diversified population. And then we have Ian Goldsmith, previously now retired Chief Operating Officer of Brakes, a multi-billion-pound UK food logistics company. Its customers include schools, contract caterers, hospitals, hotels, independent dining establishments, and various large restaurant chains. Following his retirement, he now owns his own strategy consultant business, advising venture capital organizations on food distribution, supply chain, and food-related businesses on new market entry strategies. So a great person to start thinking around the food chain opportunity. We have Abdul Rashid, who's CEO of Paulsbury Health Consultants Group, with more than 27 years of work experience in the Middle East and extensive experience working with the food industry, ranging from global 5-star hotel chains and food manufacturing operations to retail food chains. And Abdul, I think you have a BSc in environmental health from the University of Birmingham, so I was very pleased to see that. Before we take questions, may I ask each of you to perhaps take a few minutes to present some thoughts around how we vaccinate billions of people globally, including into the remotest communities, rapidly and sustainably, whilst at the same time building lasting legacy. Arvind, perhaps you'd go first.
Thank you. If at the program of this webinar, I'm supposed to make a presentation on a topic of my interest, which is future trends in the cold chain, in which I'm going to stress the importance of sustainability in all future projects. But I think the organizers are fairly generous. They've also put me on this panel. This is a last minute change. Okay. Well, today, if you look at the scenario, the world scenario, I must say the humanity has faced an unprecedented challenge because of this COVID-19. I have never faced anything like this in my 80 years experience. I've been associated with this field for the last 57 years, ACR and cold chain. But I've never experienced a situation like this. So this is challenging for all of us. Well, talking about India, India is a big country. We have a very large population, and our major issue is that we have, we do have a very large immunization program. It's about the largest program in the world about immunization. Take care of about 30 million infants, more than 30 million pregnant women, and now because of this COVID-19, we will have to vaccinate around 1 billion of people. So this is going to be a huge challenge. So there is so many institutions, so many labs working around the world to produce a vaccine and to test a vaccine. Practically every week we receive some news about the progress made and all. But as a person associated with the cold chain, I can realize what a huge problem or unprecedented problem it could be for the industry to produce the vaccine, to store the vaccine, to transport the vaccine right to the last mile delivery, and to preserve it till it is used for vaccination. It's a huge issue, huge challenge for all of us. But I think we must be prepared to face this challenge and do whatever is needed. I'm a Rotarian, and I know that Rotary International handled a very massive, a very ambitious project of eradication of polio from the face of this earth. It was about 10 to 12 years ago. And we had a huge challenge of executing this program in India, because the vaccine had to be supplied not only to the metros, not only to the mid-tiers, but to the remotest corner of India. And then we had those small the chillers, or small refrigerators, which sometimes could not operate because there is no electric supply there. Finally, we decided to have some solar operated units. So I know it was a huge challenge for all of us. But finally, we did it. And today, India is free of polio. And I think most parts of the world are free of polio now. Other countries have also carried out similar projects for them. So I'm sure with this kind of challenge, kind of preparation and the will to meet the challenges, I think we can overcome this issue. Thank you.
Thank you, Arvind. I think a great start to show the size of the problem. Never faced anything like this before in your career. Harshal, perhaps you'd like to say a few words.
Yeah, hi. It's a great topic that you have chosen, I think, at a very, very relevant time, because it's now that we can really start thinking on these terms and prepare for what we are going to have, because like we have been saying, it's a problem of great magnitude, and there are significant challenges, and from challenges you get opportunities. So since we decided that initially we just talk a little bit on challenges, there are a few things that come to my mind. One is that I spoke to a few people, since we are in Pune, and Pune has amongst the largest vaccine manufacturing facilities in the world, maybe. So I was speaking to some people there, and what I realized is that over there, the vaccine that they are producing, and maybe many of the others also, are going to be actually stored at the -20 to -30 range, rather than being stored at the 2 to 8 degrees range. So majority of the storage is going to be at that range. Now, if you're going to have that range of storage, even at the level of the primary health center or any other place where you're actually going to give out the vaccine, then having those kind of equipments to be able to store it at, say, -15 or even -20 is itself a big concern, because we are going to be going to the remotest parts of the country, of any place for that matter. So that's going to be one big challenge. Assuming you have that in place, the next big challenge is to make sure that you have the electricity that runs it, and not just having electricity, but having continuous electricity. With continuous electricity, then have a backup generator, or maybe if you're going to go for some kind of thermal storage, then that would be something that needs to be looked at. Further, you have the equipment, you have the backup. You need the personnel, the people who understands, to be in place, and not just people. You're going to backup people for even those people, because every person cannot be there 365 days. You're going to need backup people to make sure that whoever is coming is understanding, or whoever is giving those vaccines knows everything that's happening. So along with this whole scheme, I see another point that comes up, which is training. That all these people fundamentally need to be trained to understand what this process is all about, what kind of temperature are allowed to let go. Some cases you may be able to maintain, but where is it that the problem comes up? That's something that should be understood. And that's, again, a big challenge. One more thing that I see is the logistics portion, where in most cases, pharma containers are not allowed to be used as the food container. So basically, pharma and food should be used for each other. Most places will have containers which are used for food. So you have a container which is designed for -20, but it would be used for food. Now having these containers which are not for food, but for pharma, with all those safety regulations that come into picture, which would be, constant temperature monitoring, ensuring that the temperature stays there. Now the key point that comes up here is that, a vaccine is not like a food product, where at the end of it, if you open the door, if you just check the quality of the product, you know if it's good or not. A vaccine, you will only have to go by temperature logs that are there, and if they are is, you will know that this has been through the right temperature change. So that it becomes another very important point that becomes a big challenge that is to be looked at. Obviously, now that we have so many challenges, along with all these challenges like roads, other infrastructure and everything, there are the opportunities where we now have a significant amount of time. Toby said 12 months further, somehow here there has been a vaccine coming out in maybe 6 months. I don't know. We still don't know how quickly that's going to come out. But we still have at least a few months in which we can start planning for these either reefer vehicles, the storage facilities, the packs, the training, the high-end cold chain facilities, not very large facilities, mind you, because each vial is a small thing, and one container could easily operate between, say, 150,000 to 200,000 vials. So it's not going to be a large requirement, but at the same time, it's going to be a requirement. It's going to be needed at multiple places. You're going to need facilities and the cold chain at the same time, making sure that the last mile is in place. Here we can see opportunities for renewable energy, for solar cold storage. There are solar cold storages today which are being made completely independent of the grid, which have thermal storage backup. Now these need to be converted frozen if that's what's the requirement. So that's a case which needs which is an opportunity. And of course, we can push the eco-friendly refrigerants as another thing, because now that we are getting into which is big, we can have a push for use of eco-friendly refrigerants in this whole chain. These are things which broadly came to my mind. So wanted to come up as an introduction. We could always talk more about this later. Thanks.
Thank you. I think your point on training really important. If you want to vaccinate 1 billion people over a period of 4 months, you probably need about 100,000 health workers working, every day of every week. So it's a phenomenal challenge. Yes. And I was pleased to also see that, you recognize this issue of diesel gensets, and we need to think about renewable energy, natural refrigerants. Otherwise, we're going to embed highly polluting, lasting legacy technology into the marketplace. Dr. Wasif, can I come to you next to give some of your initial thoughts?
Thank you. Thank you for inviting me to this very, very key discussion. And I really thanks for having me here. Now, I have a background of global public health. So I'm going to give you a little bit of background why this vaccine has become so important to us, and why I'll be talking today about its storage and its distribution. Now, we all know that we have been waiting, the whole world has been waiting for this vaccine to come. It took some time, and some people were getting impatient. Why is taking that much time? Because so many people are dying everywhere in the world. The thing is, we don't want to bring up a vaccine that is not safe. We learned it from a very bad experience when just one person died in a military camp in US from flu. And then some of his colleagues, like 50 or 60 colleagues, they had the flu symptoms. And then what happened is we jumped on inventing a vaccine to protect our troops in that camp. So we came up with a vaccine and we gave it randomly to everybody. The result of that was 500 people. 500 people had paralysis and 25 of them died. Now these were healthy people. So the question is, why are we taking so much time and really worrying about the adverse effects when so many people are dying, right? A lot of people have asked this question to me as a public health expert. I tell them, listen, vaccines are given to healthy population. I'm not going to take a vaccine. If I'm healthy, I'm not going to take a vaccine if I'm not sure this is safe. That's why it takes time. A lot of effort in making a vaccine, but more effort in making sure that it is safe and effective. Now, talking about effectiveness, most vaccines are not 100% effective. The only vaccine that is very highly effective is the polio vaccine, which is 99% effective. All other vaccines have low effectiveness. The flu vaccine that we give every year, the seasonal flu, is only 40 to 60% effective. So if I were to jab a flu vaccine on my arm and I get a flu, then should I blame the vaccine because it didn't work? Because I got the vaccine and still I got the flu. The problem is I fell into that 40%, which was not covered, where it was not effective. But we are not talking about the 60%. 60% of the population we protected by giving this vaccine. So we have to be careful. We have to really, before we start giving the vaccine and distributing it, want to make sure that it is acceptable, because we spend a lot of effort, a lot of resources into it, and we want to deliver it so that people accept it. Storage is, of course, very, very important, because we don't, after all this money spent into a vaccine, if we have failed to store it at the right temperature, then the whole effort is gone. And then guess what? Not only the effort is gone, the blame comes to the vaccine doesn't work. The vaccine doesn't work. This was not the vaccine didn't work, it was because it was not properly stored. That's why it didn't work. So I think it's very, very important that storage of vaccine, we want to make sure that no matter what, we have to have the proper storage in order for the vaccine to be effective. Now, distribution of the vaccine is also very, very important. Where should it be distributed? Who are the ones who are to get it first? And it's not that the countries that have a lot of money are the ones who are going to acquire the vaccine. That is wrong. We have to look into where, so there should not be any inequality. We know that 90% of the burden of disease comes from the South, from the developing countries. But unfortunately, only 10% of the health resources are in those countries. So it's a shame. We don't want to do the same thing, giving this vaccine to the people, to the countries that can afford, and leaving the countries that cannot afford. So on a global public health perspective, it is our responsibility, it's the responsibility of the world bodies, United Nations, WHO, the organizations, the different NGOs, to come forward and make sure this vaccine is available. Now, like I said, we have the vaccine, we have an effective vaccine, COVID-19 vaccine, effective. It is harmless, and we have it in our hand. And then we also stored it at the right temperature. I'm just giving a scenario. We stored it at the right temperature, and we are ready to give. Now, my biggest challenge as a public health expert is acceptability. Are people going to take it? Because we know there's a generation of people who are against taking vaccines. Anti-vaccine campaigns are becoming very, very popular. So we wasted so much of time. We made our effort in storing it in the right way, and now we cannot give because of this anti-vaccine campaigns. So the responsibility, I think it's a very huge responsibility. It's a huge responsibility of the caregivers, of the people who are giving the vaccines. They want to make sure that those people understand the science, the justification of giving the vaccine. Because these days, everybody is knowledgeable. Everybody has internet and they can know everything about vaccine. They have tons of things in their head. In Europe, this whooping cough came because of a vaccine. I don't want to give it. We know that in 1970s, with this DPT vaccine, diphtheria vaccine, pertussis vaccine, people stopped taking vaccine in Europe, in Japan, because they thought this vaccine gives SIDS, sudden infant distress syndrome. They stopped taking it. So what happened? There was an epidemic of pertussis, whooping cough, after 3-4 years. So we don't want to do that kind of stuff. We want to make sure our healthcare providers, the ones who are giving the vaccine, says and is sure that he's giving a properly stored vaccine that is effective. Just not giving any vaccine. Okay, we have vaccine. I don't care. It was not properly stored. Okay, I want to give. This is my job. I'm paid. I'm going to go and start giving it. No. Then you blame the vaccine. It's a disaster. So that is why we want to make sure that we give the right vaccine, effective vaccine, safe vaccine, properly stored, and convince the people that it is for you to take it for your own benefit, for the benefit of your family and the community. Thank you so much.
Thank you, Wasif. I mean, you're adding both sort of the explanation why this is so important, but also showing that this absolutely is the third pillar. This distribution is the third pillar of the solution. We've got to develop a vaccine, we've got to manufacture it, we've got to deliver it. And I'm so pleased to hear you talk about inequality, public information. These are going to have to sit alongside this program and be part of that. I'd now like to move to Ian Goldsmith. Ian, perhaps you could give some thoughts. I'm going to ask a leading question. Have you done any back of envelope calculations about whether or not the food cold chain could quickly and easily get this vaccine out in the UK, for example? But please talk about wider thoughts as well. But we'd be very interested about that. Over to you, Ian.
Will do. Thank you, Toby. Thank you, everyone, and hello to everyone watching. So as Toby mentioned, I was the COO of Brakes, one of the leading European food service distributors, for about 10 years until I retired recently. And so my experience is across the European food service, North America, and I do have some experience across Asia and the Middle East, not so much in Africa. However, the reason I got into this was I'd seen reports in the UK talking about the magnitude of the logistical exercise to deliver vaccines out in just the UK. So I did indeed, as Toby suggested I might have, I did some back of the cigarette packet calculations in a spreadsheet, so they're definitely accurate. The thing that surprised me, I'll come to in a minute, but I wanted to say something just before that. I'm totally cognizant of the fact that food service delivery supply chains are not necessarily as well developed in every country of the world as they are in Europe, North America. But actually, whilst Brakes isn't very present in Asia and Africa, another big competitor of ours is called Bidfood, and they are present in many African countries. They're present in the Middle East and in the Far East. And so there are companies who are out there already practicing the same distribution as we did. And we do, I don't work anymore, but in Western Europe primarily. And just to be clear, that is food distribution to anyone to whom you might go and eat food out of home. So as Toby mentioned, that schools, hospitals, prisons, any restaurant chain, any hotel chain, any nursing home, any care home, an enormous variety of outlets where food is eaten out of home. And We, for example, as every other player would do, operate multi-temperature trucks pretty much across the world. For chilled is held at between 2 and 6 degrees so that you can safely transport dairy and meat products. So again, not wanting to belittle the state of the magnitude of the challenge for other countries where the food chain is less well developed in this arena. Actually, when I looked at it, 68 million vaccines to be distributed in the UK is only 18 truckloads, and that could be delivered to the entirety of the UK in 3 days in the existing network that Brakes has, because we had, when I worked there, 1,250 vehicles. The size of the packs of vaccine is actually very small. All the vehicles have continuous monitoring of temperature. And so in that basis, you can look in terms of security at the number of degree minutes that any package was above the necessary temperature. I mean, actually, it would be very rare for that to happen in any case because of the nature of the way the trucks are designed, but it obviously is possible if you have breakdowns and so on. But so my point is the volume is certainly not a challenge, whether it already exists a food supply chain. I think there are a couple of other important things. Toby, you mentioned 7,000 doctors' surgeries in the UK. My challenge, or my hope that people will think more broadly is, hold on a minute, in the UK there are 33,000 schools. So there are 5 times as many schools as there are doctors' surgeries. And within 3 days, Brakes, Bidvest and Booker, the other company in the UK, would have visited every single school in the country. So take that as an example of where it is developed. And I keep on saying, I totally respect in other areas of the world that food chain won't be quite so developed. But I think there's a huge opportunity to use that existing network. I think there are 2 other reasons why it's really important that everyone goes and talks to whoever there is in this sort of sector in food service in their own environments. One, everyone in logistics would know the only way to have something new distributed is to what I call employ the use of a shared user network. Brakes is going, and Bidvest and Booker are going to every single school every week. The marginal cost for us to deliver 68 million vaccine doses would be absolutely minuscule. I mean, I'm talking in 10 to 20,000 pounds, I mean, nothing in actual marginal cost. And of course, players then will want some recompense for what they're doing. But where you've got an established chain, it is really not costly to add a few extra boxes. The scale of them, again, to give you an example, over 3 days on all of our vehicles, you would only have to put 4 boxes per vehicle per day. And we currently carry 700, 750 in each vehicle each day. So it is really minuscule. The other thing I think you shouldn't forget is, whilst the travel restrictions are on with obviously lockdowns in various forms, whilst people are still nervous, whilst people aren't working in the office as much, and whilst people certainly aren't going out to places to eat as much as they would have done in the past, the current food service utilisation in the UK would be around 30 to 40%. That means somewhere other than the UK, there are about 5,000 temperature-controlled vehicles sat doing precisely nothing. And all of the drivers for those vehicles are fully trained in controlling them, and they know the importance of keeping temperature, integrity in product that they're delivering. So I'm not saying it's a one fix situation. Of course it isn't. But there is food service. There are food service delivery chains in every country to some degree. And of course, there are also the retail food chains, but supply chains. But don't forget the retail food supply chains. They're actually really busy because everyone's sat at home and not eating out of home. So the retail side has much less spare capacity at the moment. So I hope that's given you some bits and pieces to have a think about. Very happy to be challenged on that. But speaking as the ex-COO, technically and logistically, it would be very simple for food service players to assist with this. I hope that's helpful.
Thank you. And I think it's really helpful because I think also it gets to one of the nub questions of this, which is, do you distribute through, for example, in the UK, doctors' surgeries and then take it out to schools and outreach, or do you send it straight to the school and have the health worker there ready to collect it? Because I'm sure You know, it can be time delivery, and they can then go and vaccinate people. So that then starts to actually say, hold on, is there a way that we can do this far more efficiently and not create log jams? And I know, just quickly, we have Richard Sprenger as well on here, who might afterwards, after Abdul, who's next, just add any comments about anything he can see about the food cold chain and pharma and cross-contamination or potential risks. But Abdul, can I come to you to give your thoughts about this challenge, and also maybe anything around the opportunities of using other industries to support the solution? Abdul, over to you.
Thank you so much, Toby, for inviting me to the conference seminar. I wanted to just highlight the challenges that we have in the food industry, which could be avoided, and in case of vaccine distribution, some of the practical elements that go a long way to ensuring that the vaccine is distributed properly and in the manner that you expected. In developed countries like the UK or other parts of Europe, and perhaps in the US, etc., you've got a very strong road network and rail network, which are obviously very manage the distribution chain effectively. However, the challenges that I foresee, perhaps like with food, is in some of the developing countries where you don't have perhaps the typical strong road network. The condition of the roads themselves are challenging for transportation by road. In terms of the vehicles, the maintenance of the vehicles, and the type of vehicle that you can be using if it's going to be a road transportation. These are some of the practical challenges that are going to be faced in developing countries. One of the key issues, as with food, is the temperature control, and Dr. Wasif touched on this initially in his talk. Temperature control is a key, and with regards to food, you compromise the quality and safety of the product. And similarly with vaccines, I'm sure temperature control is a key element in ensuring that the vaccine reaches its destination at the right temperature. Now, one of the challenges that we have in the food industry in the past is drivers turning off the air conditioning or the temperature control element of the vehicle in order to save costs on fuel. Because of course, if you are managing a large distribution of vaccine, one of the key elements is to minimize costs. And one of the ways that drivers have in the past done this is by turning off the temperature control element, and of course perhaps turning it back on again as they get closer to the destination. So in the meantime, you may have 2 or 3 hours of the vaccine being transported where there's absolutely no temperature control at all. Of course, the monitoring will pick this up, but the damage has already been done. And again, here you've got an element where I believe that training of the driver in developing countries is also important, to understand that he's aware of the importance of what he's carrying. And temperature control is important in maintaining that integrity of the vaccine. So driver awareness, how to deal with breakdowns. Again, if you've got an aging vehicle in some of these developing countries which have been used for transporting other products, and then all of a sudden you're going to try to use the same vehicle which is transporting a much highly sensitive product like a vaccine, then breakdowns, are they going to be able to be managed effectively? What is the downtime of the vehicle not being operating? Is it going to be affecting the temperature control element of the vehicle? All these practical challenges are something that we have to build in terms of ensuring that the vaccine is able to be delivered to the destined site. The storage itself, the type of packaging, the type of containers, again, are they available in the country that you are going to distribute these? Particularly with developing countries, maybe the quality of the storage material, the quality of the crates or whatever they are be using in terms of the packaging for the vaccine is that going to be something that would be a challenging element for the transportation carrier? So these are some of the practical elements that I wanted to just to distribution and transportation in developed countries, which have a much stronger distribution network and logistics framework. However, we have to understand that we are talking about a global vaccine, not just a vaccine which is going to be used in developed countries. So these are some of the practical challenges which we feel that could be putting pressure on the whole issue of getting the vaccine to the destination, to ensure that the viability of the vaccination is not compromised by the basic need to have a good network of road vehicles which are properly maintained and are able to travel without breakdown, driver awareness of what needs to be done in case of breakdowns, maintaining temperature control. So some of these challenges that we've experienced in the past with food safety and distribution of food products would equally apply to the vaccine distribution chain. And here I think where we have, of course, different types of food products, but I think vaccine by nature is highly sensitive. It's very critical to maintain all these elements moving forward to ensure that we are fulfilling the task of effective distribution, maintaining temperature control, and ensuring that the vaccine arrives on site when we have all these challenges, that the vaccine is still viable to be used by the people in the population of these developing countries.
Thank you. And I think, again, you know, talking about these problems, absolutely, this issue of roads, one of the delegates has actually pointed out, and I think I mentioned earlier, that potentially we can use drones to move the vaccine out to the remote communities. They've developed a drone, and there are other drones being used in Africa already. And this issue of technology, I mean, in some countries, you know, less than 2% of the vaccine fridges in the cold chain to date are WHO certified or meet WHO standards. So this is a problem. I think it's, and this is why for me, but we want to come to the audience, but for me, the key thing is to actually get together this knowledge and this data from the roads, the maintenance, the energy, the people, the training, the data tracking, and then really try and understand what does the system need to look like, both to meet the veracity of the vaccine, but also the speed and volume that needs to be done. But can I ask...
Toby, if I may just...
yeah, I was going to say, have any questions?
Yeah, if I may just, because we didn't read Richard's bio, so if I could quickly read that, and then maybe he can give his comments. So if I could now. Yeah. Richard Springer is the chairman of Highfield International, and Highfield is a global UK awarding body and 2018 winner of the prestigious Awarding Organization of the Year award from the Federation of Awarding Bodies. Richard is a former director of Environmental Health and Government Advisor. He's one of the world's leading food safety experts and author of several internationally recognized publications. He has been involved with many high-profile food safety initiatives, including developing the most popular UK and international food safety qualifications, PIC and HACCP programs. That's Richard's bio.
Thank you. Richard, any quick comments before we invite questions from the audience?
Yes, thank you, and thank you, Surinder, for that, and thank you also for the invitation to attend the panel. I'd endorse what both Ian and Abdul have said, and I'll just try and add a few things to elaborate that weren't covered. I think one thing we've got to take the opportunity of the next 12 to 18 months that Toby said, to explore how we can ensure effective distribution, taking account all the problems that we're going to face, and they'll vary depending on the country, obviously, and depending on the availability of effective cold chain distribution. Because You can't just say use the cold chain. Using somebody like brakes is fine. Where you've got an organization that has got continuous electronic monitoring of food is critical. That's one thing. As Abdul said, we've got all sorts of problems in the food chain where people switch things off and so on. I think the other thing we've got to recognize is that as my understanding is, that the vaccine will not be unsuitable just because, for instance, it's got into 9 degrees centigrade. So if we're looking at between 2 and 8 degrees centigrade, and as we've heard from Ian, the distribution is 2 to 6, so that does leave you a 2-degree margin to start with. But if it gets to 9 degrees, the vaccine is then, as I understand it, not unsuitable. It might reduce the shelf life depending on how long it's at 9. So the problem is that if it's 5 minutes at 9 degrees, it's not going to make any difference whatsoever. If it gets to 30 degrees for 2 days, that might be a major problem. So it's not black and white that just because something's out of temperature, that it immediately becomes unsatisfactory. What we need to do, it's a time temperature combination, and there are products on the market that you could attach to a vaccine box, as I understand it. Well, certainly you could do this on the food side. The problem is it's quite expensive to apply it to each particular food item because of the intrinsic value of food. I don't know what the intrinsic value of a vaccine is, but the more expensive it is, the more viable it becomes to either attach a tape or a chemical to either the individual box, which changes color or changes form if a time temperature combination has happened that has rendered that vaccine inappropriate. And that, to me, is something that needs exploring over the next 12 to 18 months as a cost-effective way of monitoring the effectiveness, the remaining effectiveness of the vaccine. That's one thing that's, I think, important, because in many countries, as Abdul has said, we face challenges with fluctuations in temperature of the cold chain, undoubtedly. Another thing, Toby, you mentioned, well, perhaps we could have time deliveries and people could meet them, for argument's sake, at schools and so on. I think that is going to perhaps be fraught with difficulties, in that one of the problems that we find is that the driver arrives somewhere at a food business and there's nobody there. So he unloads and leaves it on the doorstep. Now, if you're in a country that the temperature is 30 or 40, 45 degrees centigrade and the food's left outside of school because the person's not there, then you're going to have problems. Unloading and loading is one of the weaknesses of the cold chain that many good businesses will deal with, and they'll have systems for dealing with it. It's not those we're talking about. It's the something that's different, and it's setting that up could be a problem. You need to ensure that there will always be somebody available, maybe not the health worker, somebody who can be there when the vehicle arrives and take it into a suitably operated facility, chiller facility, to avoid this abuse. But the two key things to me are within the vehicle, permanent monitoring, temperature monitoring, data loggers, thermographs, etc., and having something that you can tell whether that vaccine has been abused from a time temperature combination. Training, I think Ian covered this. Everybody in the food industry is trained on temperature control. They know the way that the vaccine should be handled. I think the other thing, we've just got to make sure we've got time. We need to make sure there isn't a contamination risk. We need to make sure there aren't countries that legislation would preclude this from happening, or standards or codes of practice that would preclude carrying vaccines and other things with the food. Now, that's a theoretical problem, but it can be sorted out, I'm sure, because we've got time to do that. Because theoretically, there is a cross-contamination risk. Theoretically, if it's handled properly, I'm sure professionally run organizations could deal with that in this situation without a problem. But there are certainly some organizations in some countries that I would have concerns that the cross-contamination may to deal with that issue as well.
Thank you for those comments. I think just a couple of things. Obviously, with vaccines, freezing is a big issue, and we've got to make sure it doesn't go that way. And obviously, as you look at the main challenge, which is around the global south and developing markets, it's going to be the outreach and the last mile, where the heat or the freezing and using micro chillers and the roads and all those issues really do become the big challenge, and where there's a lot of work to be done. Surendra, did we have any questions you wanted to put to the panel?
Yes, sure. I mean, this sort of ties in with what Harshal said about keeping the vaccines in storage at even minus 30 degrees centigrade, if I remember correctly. And so this is a question that is a small one, but it's from Bala Murugan, who's with TCTI. It's based in Dubai. And he says, how will you store vaccines at minus 80 degrees centigrade, very low temperatures? So that's his question. And maybe Harshal would like to take it up, or Toby, it's up to you to suggest who to.
Well, I'll leave it to the panel for those who want. I would just say at the moment, I'm pleased that the work we're doing with vaccine developers in the UK, Oxford and others, they're looking at 2 to 8 degrees C, but I am aware that we do have vaccines at minus 80 as well. So that just adds another layer of challenge. But anybody at the panel, routes to deliver minus 80?
Well, to start with, there are a couple of questions regarding the vaccine being at minus 20 to minus 30 range. That is for the one which I spoke to, which is being manufactured near Pune. Of course, that may not be the generic trend for all the vaccines that are being produced, because worldwide there are multiple agencies which are looking at producing vaccines. So different vaccines may require different temperatures. But yes, there would be ones which need minus 20 to minus 30 temperatures for storage. They would typically be in the powder form, which is basically a process which they remove the water out of it. And then you put in diluent and create the vaccine just before it is injected. So broadly, that's what is expected. So we could be having a requirement of freezers at last mile level, which would be one of the major requirements. In terms of vaccines at minus 80, I'm sure it could be possible. If it's basically the requirement given by the manufacturing company, and if it is there, yes, it needs to be taken up using cryogenics or similar technologies.
So we're looking at Birmingham at cryogenic opportunities for how we could deliver that, but obviously that's going to create another layer of challenge. So hopefully we will be at the 2 to 8 range, because that's sort of far more understood. Anybody else to have any comments on that?
Sure. I mean, it's more of a comment really, and this is coming from Sushant Kumar Lokande. And he says, I have developed a modern vaccine carrier with drone connector attachment for faster transportation of COVID-19 vaccine. And also the vaccine carrier is designed with phase change materials, so in which vaccine remains at 2 to 8 degrees centigrade all time and remains potent always. So it's more of a comment, Toby.
But I think it's a very important one, because if you come back to the issues over roads, maintenance, all of these things, actually the use of drones, when you see them, where they're being used for blood in Africa and so on and so forth, this modal shift offers great potential, I think, to leap forward to new routes to get it out into the outreach. But obviously we've got to look at the size of the problem and the requirement. Other questions we've had up?
Not really. I mean, someone's asking about this. One's from Vignesh Ilango, and he's a design and application engineer. And perhaps this has been answered already, but I'm just going to read it out all the same. It says, I would like to know the latest advancements in vaccine storage and transportation, and recommend some areas to do research and development regarding these. So he wants to know the latest advancement on transport and storage of vaccines.
Well, there's a lot of work going on, because you've got the chain from right from the factory through to the last mile micro chiller, so pallets right the way through. I think there's a lot of work, and the area where we're focusing on, but there'll be others, is particularly around the use of sustainable and renewables to drive the technologies, phase change materials. So how can we move away from using diesel gensets and diesel on vehicles to provide this solution? So that would be a key area of focus. One of the questions I've seen come up is around, yes, we're talking a lot about the food cold chain. And I think it was really that what we're trying to do is broaden out the discussion, not saying the food cold chain is the answer, but broaden out the discussion that, you know, we've got to look at new methods, out of the box thinking, given the volume and the speed required. This isn't about, when this vaccine's ready, it's not going to be about storage to drip feed it out to a marketplace. We're going to have to get this vaccine out really fast, really quickly, if we're going to get economies back kick-started again. So, and particularly in the global south, the developing markets. And from my perspective, it's bringing together everybody who understands cooling cold chain to come up with challenges and issues. So that's why I think we are having the food cold chain people here. Not to say that's the route, but to bring their thinking to the table.
I have a question, Toby, and I think Abdul Rashid spoke about it briefly, and he spoke about driver behavior. And so I just wanted to know if members of the panel could answer, how can we give a holistic solution to vaccine delivery and storage in terms of human behavior? Because it's not just the availability of reliable electricity network, but also at the end of the day, it's about who's going to be transporting it to the last mile. And there is a need for education to build that awareness. And so it's a holistic strategy that we're looking at here. So I don't know if someone could answer that, and I would like to hear maybe from an India perspective, Harshal or Mr. Arvind, if you could, or Dr. Wasif. And
could you just repeat this? Yeah.
Oh, you want me to repeat the question?
Yeah.
I think, Arvind, you're probably about to talk, so maybe while you get ready, Harshal or Wasif, you could answer the question.
Yeah, I just. Can you repeat this?
Do you want me to repeat the question, or?
Yeah, please repeat the question.
Yeah, sure. So, you know, as Abdul Rashid had spoken about driver behavior. I mean, they tend to switch off when they're on the highways and switch back on, and so that's going to affect the integrity in the case of food safety. And here we're talking about vaccine integrity. And how do we, in terms of giving a holistic solution, so it's not just about ensuring electricity supply or power supply, but it's also about the human behavior, the intervention of,
That's, I think, a very genuine problem, which we do face on our Indian highways. And what I feel is probably the need for proper training at all levels, but especially the people who drive the vehicle or look after the vehicle right from the center of production to the center of delivery. So this kind of, this kind of information, imparting the feeling of responsibility of carrying this, this most expensive material, important material. I think this needs to be done, and I think we'll have to organize some special training programs, even for the people who handle the transport part of it. And then, of course, there are controls, there are data loggers, and there are remote control, there are GPS controls and all that. All those are already there. But then, how many people really are making use of it? That's another question. But all those questions, will come when you impart proper training for this particular problem.
And I think, as you said, we have to use, good cloud monitoring right the way from the factory through to the micro chiller at the last point, so that there's temperature capture. I think, if I'm correct, Surendra, we've sort of run out of time for this session, and you've now want Arvind to say a few words and thoughts about sustainable cold chain. I think we've got about 10 minutes or so before you're looking to wrap up.
May I say a word here, please?
Yes, of course. Sorry.
Yeah, I have one. I see one question is asking why pharmaceutical industries are not participating in this gathering. I think it's a very valid question. Why I'm saying it, because there are now currently like 160 pharmaceutical companies racing to deliver or produce an efficient vaccine. So my question is, after they're spending so much money into it, I would think that they should take also the responsibility to spend some more money in making sure the vaccine that they have made is transported and delivered effectively. Because you're putting so much money into it, and then your vaccine doesn't work, and you get blamed because your vaccine is not working. So I think they have to invest money to make sure that this vaccine is transported in the right temperature and is given and stored and given effectively. So I don't know if pharmaceutical companies are interested into it, but I think they should be interested, because after all, it is their product. So they get to be blamed. So I think investment needs to be there.
And I should say that we're working very closely with a number of the manufacturers and developers and researchers of vaccines who are very keen to both in India, the UK and other countries, to understand the distribution of the vaccine and support and help in making that work. So absolutely, they are now recognizing this is the third big challenge to the problem. And in itself, it's got a lot of big areas to solve. So as I said, we're coming close on time, so I'm going to have to be slightly rude and cut off further questions. And if I could ask Arvind, you to give your presentation. As I said, I think we've got about 10 minutes before we're hoping to wrap up.
Okay, I think, thank you, Toby. Now this is going to be a challenge for me, because I normally present this topic and take about 1 hour of talk, but this is going to be a 10 minutes affair. So I'll try to be actually rushing the whole thing. Well, I will not go into the agenda, because it's clear. I just want to say that I normally like to start from the basics, but all of you are experts, you know what is cold chain. I only want to talk to you about the whole gamut of cold chain, which is now a lifeline for the modern world, for the food and the pharma. And you can see many lines here, right from dairy, fisheries, meat and fish, meat and products, meat products, poultry products, fruits and vegetables, then ready-to-eat foods, and the pharma. So all these sectors are covered under the cold chain. Next. Well, there are various components in the cold chain. What is missing here is the small, the freezer or the refrigerator used for the used for the vaccination. Yeah, with all the goodies of the cold chain for both the food and the pharma, we do have challenges like global warming through refrigerant usage and leakage, high electrical energy usage, water requirement in plenty, and the problem of damaged and spoiled produce disposal. Well, what is the future scenario? Sustainability will be the main mantra for all the development. A simple definition which Hfc gives is providing the needs of the present without detracting from the ability to fulfill the needs of the future. A simple definition. And sustainability is going to be of importance and operation of all cold chains. Projects will involve many green features in terms of materials, styles, and construction. And we may see projects with 5-star appearance, with better environment and amenities to staff and workers. Let's see a couple of views. Yeah, this is one of the latest projects in India. This is another one, modern avatar. Well, what is the post-COVID scenario? COVID-19 is an unknown virus which has posed a serious health challenge to the whole world. And as I said, I have never experienced anything like this in my 80 years. Current issues should pave way to newer techniques and newer outlook towards food supply, cold chain, and distribution. And the same thing applies to the pharma cold chain. The cold chain and logistic services must be kept operational to maintain food distribution even with lockdown conditions and restrictions imposed on trade, commerce, and transport. We have been facing this problem. COVID-19 has also thrown a big challenge for the pharma, logistics, and supply chain. Number of medicines have to be distributed normally to all the communities for treatment of affected people. That is COVID issue. And large number of institutions and companies are now trying to produce and test vaccines to prevent the pandemic. The real challenge is the storage and logistics for distribution of all the vaccines all over the globe. Now, everybody wants the vaccine yesterday. That's one problem. The producers or those who manufacture, those who produce, they are facing this challenge. They are doing their best. Corona does not spare anyone. This is a fact. At every level in the cold chain, we do face problems to the equipment, the process, to the people working, and all other related factors. So you can see whether it is a chilling process or it is a freezing process, everywhere this danger persists. Yeah. Now, the concept of green chain, cold chain projects, which I have been promoting on a global scale for the last 12 years now. There are some features which I have listed here. It's going to be a short presentation. Eco-friendly environment for the plant. Location near rail and road terminal to reduce the transport distances and the expenses. Eco-friendly plant layout, which is again very important. Efficient building design, using eco-friendly and recycled material. This is a part of the green building design. Efficient thermal insulation. Now this is a very important issue for all cold spaces, because we understand the function of a refrigeration system, but many of us do not understand really the need for the efficient thermal insulation. The refrigeration system works for a certain number of hours just to maintain, cool the product and to maintain the temperatures. But the responsibility of thermal insulation is every second, every minute, every hour, and for the entire period that the product is there in the storage. And then we have eco-friendly and energy-efficient refrigeration cooling system. We all know refrigeration is the heart of the whole cold chain system. We have some wonderful output from a refrigeration system, that is waste heat recovery. Now, every refrigeration system collects the heat from a place or a product or a process and then rejects it to the atmosphere. Now, if you can recover a part of this heat and use it for gainful purposes, it's a free energy, and you can use this energy for various applications. I'll come later. Effective control systems control the controls now, and we have a separate slide on that. Energy efficient lighting and electrical systems. Now gone are the days of using those CFLs and all. We are using the latest LED and other electrical appliances which have high energy efficiency. Then we have use of natural light, natural ventilation, noise control, fire safety, all parts of the green building design. Next. Use of renewable energy. Now there are different forms of renewable energy. We'll talk about it in a slide that will come later. Minimum water consumption and recycling. We will have rainwater harvesting in all projects, and then use of energy saving accessories like VFDs, energy recovery units, strip curtains, air curtains, and also water saving devices. And finally, we should have operational practices to suit green character. This is where the importance of training comes up, because you may design a very nice project, green project with green features, but then it has to be operated also to suit this green character. Well, talking about the refrigerants part of it. Now we know the currently used Hfc refrigerants have to be phased down as per the Kigali agreement. We are looking for HFOs now. HFOs 449 and 448 in place of R404A, and HFOs 1234YF and HFOs 1234JD in place of R134A. These are not zero GW refrigerants, but they have much lower GWP as compared to the refrigerants currently used. HCs will have a bigger application range with a higher limit of 500 grams. You know that the old limit was just 150 grams, which limited the application of HCs, which are hydrocarbons basically. They are pure natural refrigerants. And now the allowed limit has been increased to 500 grams. So this opens a new horizon for the plants which can have bigger size, like for example, the walk-in coolers, little larger size coolers and all. Ammonia will continue to rule and midst the mids and large size plant segment. Ammonia has been there for 150 years. The only issue is about the toxicity part of it. And that is why low charge systems have already been developed, and they are going to have a very good share in the coming years. Ammonia DX systems. Now, DX is a direct expansion systems, which normally we use for the HFCs. Now, ammonia DX systems have not been used in the past. We have developed those systems. In India, we have put up 4 projects which are now running on ammonia DX systems. And we usually the ammonia plants use water-cooled condensers, but we are now using even the air-cooled condensers with evaporative inlet air cooling and full automation.
Hello. Hello, Assalamu alaikum. Hello. Yeah, what is it?
Is back now as a refrigerant. Yeah, as a as a refrigerant. Although CO2 is a very old refrigerant actually. We had almost forgotten about it. But today, we feel that CO2 will come back as a refrigerant in cascade systems, in frozen food plants, in all low temperature plants, and secondary refrigerant in retail sector. So in the future for the CO2. Absorption systems working on lithium bromide and water. They will find applications for temperatures up to 0 degrees. Ammonia water absorption systems will be a choice for low temperature applications.
मुझे कांटेक्ट करें, मिलते हैं, मैं फ्री हूं, जब भी उनके हाथ में वक्त है तो बताएं मुझे, मिलूंगा इंशाल्लाह.
Yeah, this is a pictorial view of P&ID for ammonia DX system, which works like any other HFC systems, full automation and a very low charge of ammonia. It's going to be a popular system for projects in the future. Energy consumption is always a focal point in the operation of cold chain, and it will continue to be so. The plant and equipment selection will essentially be based on low energy cost rather than low equipment cost. Current trend, sometimes people do go in for low equipment cost without giving due consideration for the energy. But it has to be done now in the years to come. Whereas energy requirement depends on the design of the structure, thermal insulation and cooling requirements, lighting and other parameters, the energy efficiency achieved mainly depends on the design, selection, operation of refrigeration system, automation levels and operating practices. There are so many energy saving devices which are currently being used, and they will have better use, greater use in futures. Just kind of evaporative condensers, which has got a best thermal performance among all water-cooled condensers. And on the bottom side, you can see the air-cooled condensers with pre-cooling of condenser air, where I have just explained. Yeah. And this waste heat recovery system, you can use this free hot water for gainful purposes, like for your processing, for your washing, cleaning, toilets, and any other application that you have. It can also be used for the subfloor heating or low temperature cold stores, like minus temperature. It's like we said, the COVID vaccines, like minus 20, 30. So those floors have to be heated, manually heated to keep the low temperature system. The sky is the limit for the operation of the controls. Here you can see different lighting conditions, the old system, the systems with the LED lighting, and the use of natural light in the attic space. So here we have use of renewable energy. Solar PV systems are being used now for the farm level units to large cold stores also. There are biogas units using biogas for generating hot water for operation of the plant, processing, washing, etc. And as I said earlier, absorption systems even working on solar. This is a large cold chain unit working on solar energy. It's a partial production. And here this figure shows you in a nutshell how a green cold chain or sustainable cold chain would look like, with all the facilities mentioned around this. I hope you can see this picture clearly. In case somebody wants more details or the copy of this picture, we can share this. There's another view section part of it, elevation part of it, showing all the features of a green cold chain project. Next. Yeah, and this is probably the last slide. ASHRAE, when I was a member of ASHRAE Refrigeration Committee, we decided about the production of a sustainable refrigerated facilities guide and for the refrigeration systems also. So I was a member of this committee, project monitoring committee. This book has been published. It's the only book on sustainable facilities in the world. And ASHRAE, I mean, anyone can get it from ASHRAE. This is the first of its kind book. What next? This is a very important question. Very few people are thinking about sustainable and green cold chain projects. I have been working more or less, I would say, on my own will and wish, and I made it my mission, to promote this system. So we'll have to work on some kind of evaluation of green ratings and then offer recognition incentives to projects based on green ratings. Yeah, and we come to the conclusion. The cold chains for food and pharma are integral parts of modern human life. Concept of sustainable or green cold chain needs to be developed based on eco-friendly and energy-efficient technology in construction, operation, and all cold chain projects. And the time to act is now. Thank you. We welcome. Any questions? I think I did it in 10 minutes.
Surrender. Thank you very much, Arvind, for that. It was really interesting to see what's going on in the sustainable side. Surrender, can I pass over to you to finish off? You're on mute.
Sorry. Thank you, Mr. Arvind and Toby. Yes, with that, I would like to invite my colleague Frederick Paye to take us through the sponsor recognition ceremony and give us a few words. Frederick, over to you.
Thank you very much, Surrender, and welcome to all of you, distinguished panel of speakers, and those of you in the audience that have tuned in to attend this highly insightful and informative webinar, I hope, on a very important topic indeed. So welcome to all of you, and thank you very much for your contribution from around the world. Now, obviously, I would like to proceed with the vote of thanks and the ceremony. If you allow me, please. Right. I would like obviously to thank our partners today, our strategic knowledge partner, ACR Project Consultants, for their valuable contribution, as well as our strategic HVACR recruitment partner, carriersbay.com. And now I would like, if you allow me, to take you through a few of our digital initiatives as well, and as well the magazine that I hope you are all familiar with. You may know that our website, climatecontrolamy.com, is partly mainly news-driven, but we also launched last year a more global portal entitled climatecontroljournal.com, which is divided into geographical areas. So wherever you are in the world, you can obviously log in and check what are the latest news affecting the industry in your geographical area. We are also celebrating this year our 15th anniversary, and we are extremely proud of it, and thankful to all our readers for their faithful support, and advertisers, of course, as well. And here you have on your screen a few samples of our editorial coverage, and I can safely say that what has made the success of the magazine so far is the impartiality and objectivity of the editorial coverage. And you will also notice that most of our stories are exclusive and not only obviously press releases. So you have some samples on the screen that are displayed here. For instance, here you have an interview with the president of AHRI in the USA, Stephen Urek, and other more recent articles as well. As you can see, the COVID-19 pandemic has taken quite a lot of space, obviously, in our publication. And notwithstanding the importance of the online and printed directories, which are issued on a yearly basis, the Climate Control Guide and Directory is mainly a directory of suppliers of HVAC our equipment wherever they are based in the world, provided they are supplying to the region. And the equivalent portal is climatecontroldirectory.com. And we shall release the new edition in November, as well as for the refrigeration buyer's guide, also enjoying its own dedicated portal, refrigebuyersguide.com. And hopefully the new edition shall be published during the Gulf Food Manufacturing Exhibition in Dubai. As you may be aware, physical events are now allowed to resume in the Emirate, in the country, as long as we adhere to certain very strict health and safety guidelines. Now, I would like to take you through our upcoming events and webinars. We have on the 30th of September, a webinar on IAQ, which is very important indeed these days, on strategic solutions. And it will feature for the first time a profiles track of champions of the big fight, basically companies which have developed products or have existing products, but designed to fight the COVID-19 pandemic. So those companies will be profiled in this special track and will be able to present their solutions to the audience. On the 14th of October, we shall be holding the 4th edition of our Client Consultant Contractor Conference with a co-located event entitled IT and HVAC, dedicated to IoT and the prominence of the information technology in this HVAC sector nowadays. And hopefully it will be held as a physical event in Dubai, in a hotel, failing which, obviously we shall duly inform you in due course. It will be converted as a webinar, as the situation remains quite unpredictable. This event is so far sponsored by Mecca, Samsung, and Royal Gulf as bronze sponsor, as well as CarriersBay.com as our HVACR recruitment partner. And the last event of the year for us is the biggest one, indeed, and also in its 10th anniversary, namely the Climate Control Awards, which reward the best products, best projects, best initiatives of the industry in the past year. The new category shall be unveiled very shortly on a dedicated website, climatecontrolawards.com. I shall remind you that all the entries, submissions are free of cost. The only costs come from either attending the event in a physical manner or sponsoring it. So you are more than welcome to attend that. And on that note, I again thank you very much for your support and attention, and wish you all a very safe journey indeed. Thank you very much for tuning in. Thank you very much. Back to you, Surange.
Thank you, Frederick. And it's my duty now to give the vote of thanks. And I do believe that it's been a very useful session, and that we have learned quite a bit from each of the panelists. So on behalf of CPI Industry, my thanks goes to every one of the panelists, and Abdul Rashid, who's the Chief Executive Officer of Pulsbury Health Consultants. Thank you so much. Arvind Surange, Chairman and Managing Director, ACR Project Consultants. Harshal Surange, Director and CEO, ACR Consultants. And Dr. Wasif Alam, who's an independent consultant and former Director of Public Health and Safety Department at the Dubai Health Authority. Ian Goldsmith, the Chief Operating Officer of Brakes. And Richard Sprenger, who's the Chairman of Highfield Awarding Body of Certification. Sorry. I'm also immensely grateful to Professor Toby Peters with the University of Birmingham for being such an inspiring force and leading the discussions. Thank you so much, Professor. Speaking for all those attending this webinar, I can say that we have learned a lot. I'm pleased to say that while the webinar was on, my colleagues in editorial have been busy taking notes, and it will be our privilege to publish a post-event report, a detailed post-event report across our print and online platforms, and thus we'll be able to amplify the key messages to our vast readership base the world over, those that could not attend today's event. As CPI Industry, we see this webinar as a first in many on the topic of vaccine and cold chain. Many years ago, we started off with cold chain with a food safety and quality assurance focus, and it's grown into a significant event, and we anticipate that this event also, this particular webinar, in some time in the future, will also grow significantly. The discussion is really an iterative process, and we hope to soon announce the date of the second edition of this particular webinar, Vaccine Virtual. And we have taken note of what one of the members of the audience said, that we need to see more pharmaceutical companies, and we take that comment very seriously indeed, and we assure you that the next edition of this webinar will certainly see a healthy participation of pharmaceutical companies. And on that note, I thank you all for attending. I do believe it's been a wonderful experience. Thank you once again, and do stay safe, well, and healthy. Bye for now.